Hello everyone. Now we'll see what is a composite design pattern. So composite pattern, the intent of this composite design pattern is that the composite objects composite the objects into tree structure to represent a part whole hierarchies. Composite lets the clients treat individual objects and compositions of objects uniformly. Okay, so client will refer to the component, and the component can be either a leaf component, leaf node, or it can be a composite component. So you can imagine that the component is like any file or a component which can be either a file which is a which contains something, or or it can be a directory which contains lots of files, right? So this is represented. This tree structure can be created using a composite design pattern. So let's look at it using a actual program. So let's create a class component. Okay, component will basically have only one method, which is a virtual void traverse. Okay, so you should be able to traverse that component, and let's create the concrete implementations of it. One is a leaf, and that will have a value, right? Int m value, and it will have a constructor which will take a value, okay, and it should simply copy it in its member, right? So that's the constructor, and it will have a void traverse, and this method what it should do is simply display the value, okay, m value, right? And the another class will be composite class, com composite, and that will be derived from component. And now this class, what it will do is it will uh, what it will do is it will maintain a vector of components, okay, m components, you can say m components, and it will provide a method void add, and this shall take a component object component star c, and uh, it should simply add it in its member list, and it should override this traverse method. And this traverse method, what it should do is iterate on all the elements of m components, okay, and it should call a traverse method on it. Okay, so that's the idea of composite class. Now, when let's create the actual instances of this class. So let's create four composite objects. Okay, comp 4, right? And let's initialize them I0 to I is less than 4, I plus plus, I plus plus, and similarly for let's add three leaves in each of each component. So j is less than 3, j plus plus, and what I'm going to do is comp of I dot add element, and here I'm going to add a leaf component, and let's give the index I into 3 plus j. Okay, so that will create a uniform indexing here. And with this, now let's add the three components as the child of the first component. Okay, so that we can do by iterating from 0 to 4, and then comp of 0 dot add, and here simply add comp of address comp of I. Okay, so that will add in the directory structure correctly. Maybe this is not required. That is strange why it is not allowing it. Okay, so what did it say? Comp. So that's a composite, and which is also component. So we are sending the address of that. So, I don't know why it should be a problem, but let's wrap it inside this. No. Conversion is an inaccessible base class component is not allowed. Okay. So that's because of this, because we are not using public, right? So that is fine now. So now let's display int I is equal to 0, I is less than 4, I plus plus, and simply call comp of I arrow traverse. So uh, we are going to call I we are going to call a traverse method on the object, right? So with this, now if I run, ignore it's 0 to 4. Um, so are we missing something here? This is cout slash n. Okay. And this container of 0 dot add, we are adding that object. And this is less than 4, so that should be fine. I dot add, so this is dot add, this is fine. And components to size, we are calling traverse, and we are simply printing it. So should be fine. That's what I feel. Okay, it displays it 0, 1, 2, 3, 4, 5, and then it's crashing. So why it should crash is what we don't understand here. I into 3 plus j. So starting from this, we are adding these elements. And the drivers. Okay, so just for testing purpose here, I will copy this source code and run it. So as you can see, the first element will print all the elements because the first element has 0, 1, 2 as its children. Okay, and these elements are also the children of the first element. So 3, 4, 5, 6, 7, 8, and 9, 10, 11 comes from there. And these are the individual components that we have here. Okay, so this is how we create a tree structure, and this is quite useful when we want to cache the directory structure of our disk, and this is how we use it. Thanks for watching. I'll close this.